We're out in Ontario, California today at BZ Moto Engineering, and standing here next to me is BZ Azarioa. You've been doing a lot of engine calibration, a lot of tuning on your dyno. What are some of the secrets? What are some of the ways that you can maximize power and reliability?
A key component of tuning, in addition to optimizing ignition timing, is air fuel ratio.
And typically, how do you guys read that as tuners on the dyno so that you know if you're in the ballpark?
What we do here at BZ Moto Engineering, we give the engine what it wants. So we have an opportunity to look at what air fuel ratios the car wants for optimal safe power and apply it accordingly. Not only do you want to tune the entire engine as a package for the ideal air fuel ratio, but you also want to pay attention to each individual cylinder, how they differ. And not only will you have a setup that is more reliable, you have one that makes extra power to boot.
A lot of times people have used EGT sensors in each cylinder. What are the pros and the cons of that?
The EGT is really better than nothing. However, it doesn't give you the precise feedback and the quick feedback you need to be able to do it properly. Using an individual cylinder O2 sensor would be ideal.
And you've used that before. You actually kind of pioneered something here. We pulled this out of your old race car, but this right here is something you did. Tell us a little bit about it.
Well, it is a twin channel device, two of them bundled together, and it allowed me to monitor each individual cylinder in my natural aspirated record-winning race car and tweak each cylinder individually to extract a little bit more power. When every horse counts, this spelled the difference between winning and defeat.
Now, AEM's come out with a 4-channel controller just to do exactly what that unit did, but it also has something else with the back pressure feedback?
Yes, the back pressure device is extremely important, especially in turbocharged applications. And I've seen a very strong correlation between back pressure and changes in air fuel ratios.
Okay, so today what we're going to do, we're going to take the vehicle, get a baseline of it, tuning it the old-fashioned way first.
We're going to go and look at every individual cylinder and try and optimize each cylinder by bringing them closer together in AFRs and seeing if we have any power difference.
Let's go hit the dyno.
Sounds good to me. We now finished the first run. Now let's take a look at the individual air fuel ratios for each cylinder. You can see that the blue line, which depicts cylinder 1, shows a very lean mixture around the 5,300 RPM mark. Look at another cylinder here. Wow, cylinder number 2, not as efficient. We have a cylinder here that is extremely rich, hovering around the 4,000 RPM band. It may be a little bit hard to see, but the yellow line is a cylinder 4 AFR. And as we see, it's pretty straight and very nice. It looks very optimal, and it's a cylinder that we really don't have to touch. Now, based upon the data we have in the log, I now have an opportunity to go into the AEM Tuner software and adjust each cylinder accordingly. I've adjusted accordingly trim for cylinder number 1, for 2, and for number 3 as well. Number 4, as we mentioned, is not touched whatsoever, and now we have an opportunity to try and get all the other cylinders to be very similar to number 4. Now, the importance of the pressure compensatory circuit inside the 4-channel Uego system is extremely important. As an experiment, we disabled the system and performed a very quick dyno run to see what effect this had on the air fuel ratios in each individual cylinder. As you see from the chart here, we have a significantly richer air fuel ratio mixture. Extremely important if you're building multiple engines with different exhaust housings or back pressure based upon exhaust system size. Okay, we're now back to look at some new logs based upon the corrections in the cylinder trim using the AEM Tuner software. And as you see from the chart, we now have a very smooth collection of individual cylinders. Once again, a huge opportunity for increased power and reliability. If you remember, we had one cylinder, cylinder 1, that was extremely lean. And if we try to push the envelope any further, we may have a bit of a failure in that particular cylinder. But with this, we now have a safer, more powerful setup that the consumer can enjoy day in and day out.